All right, we're on lesson 1.2, and this is task 3, radicals and rational exponents. All right, so it says evaluate numerical expressions involving rational exponents. You can use the rules that you derive from the properties of exponents for rewriting expressions involving radicals and rational exponents to evaluate expressions with rational exponents. All right, so definition. This is something that you need to commit to memory. For any real number, a, and any integers, a and n, where n is greater than 1. Okay, so if you notice, n is in the denominator, so it has to be greater than 1. All right, so it says a to the nth root, or the nth root of a equals a to the 1 over n power. Okay, so whatever is in the denominator becomes your index. All right, so you've got a raised to the m over n power, and that equals the nth root of a to the m. Again, the index comes from the denominator. The numerator is your power, and it can be written under the radical, or it can be written outside with parentheses. So these two things are equivalent. All right, again, definition of rational exponent. Need to commit that to memory. All right, the properties of integer exponents can be extended to rational exponents because rational exponents were defined to be consistent with the properties of exponents. All right, so the difference here, remember, rational exponents just means now you're looking at exponents that involve fractions. Okay, and again, that's why we are looking at this here, because we have exponents with fractions now, but they follow the same rules as your properties of exponents. All right, so it says, answer the question to explain how the expression was evaluated. All right, so if we have 9 raised to the 3/2 power, that's the same thing as the square root of 9 cubed. Okay, again, the denominator becomes the index, the numerator is the power. All right, square root of 9 is just 3. 3 cubed is 27. Which form of the definition of rational exponent justifies writing 9 to the 3/2 power as the square root of 9 cubed? All right, so we've got a to the m over n power, and we're going to nth root of a to the m. So that would be this one here. And the only difference again between this one and this one is this one has the parentheses, and because this has parentheses, that's the one that makes this true. All right, so it says a to the 2/3 power equals the cube root of 8 squared. And the cube root, so we can do 8 squared first, so we're doing underneath the radical first. 8 squared is 64. Cube root of 64 is 4. Which form of the definition of rational exponent justifies writing 8 to the 2/3 power as cube root of 8 squared? All right, so this time we did under the radical first. You still have a to the m over n power. This time we did the power first before we did the index. So that means that's the difference in the parentheses, okay, is the order in which it's done. But they're going to be equivalent. All right, so if you have 4 to negative 3/2 power, that's going to be the square root of 4 raised to the negative 3rd power. All right, square root of 4 is 2. 2 to the negative 1 or negative 3 power. Remember, a negative exponent can be moved to the bottom, properties of exponents. So 1 over 2 cubed, and 2 cubed is 8. So 1/8 would be your answer there. What property of exponents justifies writing 2 to the negative 3 power as 1 over 2 cubed? And that's your negative exponent property. Okay, again, all of those properties you should have in your notes, but you also want to commit those to memory. Not just word for word that you don't understand them, but memorize them in a way that makes sense, that you understand them. All right, so we've got 64 to the 2/3 power minus 125 to the 1/3 power. So they're going to rewrite this as the cube root of 64 squared. So that's just rewriting this rational exponent as a radical, and then minus, and they're going to write this the same way as the cube root of 125. All right, so the cube root of 64 is 4. 4 squared is 16. And then minus the cube root of 125 is 5. So 16 minus 5 is 11. Okay, which form of the definition of rational exponents justifies writing 125 to the 1/3 as the cube root of 125? All right, so this doesn't have an m and an n, it just has an n. So it's going to be this first definition here. All right, so that's just evaluating using your exponent properties. If you have any questions, please let me know. Lesson 1.2, Task 4. Simplify algebraic expressions involving rational exponents. The rules for converting between forms with radicals and rational exponents can be used along with all of the properties of exponents to simplify algebraic expressions involving variables and rational exponents. Determine the properties that justify the indicated steps taken to simplify the expressions. Assume all variables are positive. All right, so we're given, this is in parentheses, so we've got the product of 64y squared, all raised to the 3/2 power. Okay, so they're going to rewrite that as 64 as 8 squared. Okay, so they're just rewriting that as an exponent. Okay, so 8 squared times y squared raised to the 3/2 power. Okay, then they have a they're going to rewrite this as 8 squared to the 3/2 power. So they're using this as a power of a product. Okay, so we've got a product here raised to a power. So that's going to be a power of a product here. All right, so we simplify down through here and you can see that it ends up being 512y cubed. Okay, just using your properties of exponents. All right, so it says choose the words to complete each sentence. The property that justifies writing this as this is what property? All right, so this is a product to a power. So it's going to be the power of a product. So see, these are a little bit tricky because you've got a product of powers, a power of product. They've just reversed the terminology here. You've got a power of a quotient. We know it's not division. And a power of a power is a power raised to a power. So one of these first two, but it's going to be a power of a product because we had a product first raised to a power. So the property that justifies rewriting this as this, these are the power to a power. Product of a power, power of a product, power of a quotient, power of a power. All right, so again, you're just looking to choose the right terminology based on what you see. All right, choose the word to complete the sentence. The property that justifies writing y to the 5th raised to the 1/3 power as, okay, so this is a product here, same base. You're adding exponents. 3 plus 2 is 5. So what they're doing is rewriting this to make it look like this. So this is a product of powers. All right, the property that justifies writing x cubed raised to the 1/3 power as x is the what? So a power to a power, remember, 1/3 of 3 is just 1, so that simplifies to be just x. But again, that is a power of a power because you're raising one exponent to another exponent, which is a power raised to another power. All right, choose the word to complete the sentence. The property that justifies writing x to the 3rd raised to the 1/2 as x squared times x to the 1/2. So what they did is take the x cubed and rewrite it as same base, add exponents. All right, so again, this is a product of powers because you're dividing this into a product here. All right, choose the words to complete the sentence. The property that justifies writing 5 to the 1/2 times x to the 1/2 as 5x to the 1/2. So they're taking the bases and putting them in parentheses since it's both raised to the same power. This is a power of a product. All right, so that's just talking about properties of exponents and seeing how they work. That is task 4. If you have any questions, please let me know.